Why have we not yet found traces of extraterrestrial civilizations? History, like understanding the universe, has its own way of doing things. It begins with the great philosopher Arthur Schopenhauer, who also pondered the mystery of the cosmos and our places in it. Schopenhauer argued that life is a dream, and only death awakens us. Born in 1788, Arthur Schopenhauer was a famous German philosopher and one of the forerunners of existentialism. His philosophy is permeated with thoughts of the vast expanse of the universe and man's role in this cosmic ocean. He began to realize that sometimes the answers are hidden in questions we haven't even asked. He came to realize that each of us is part of this vast universe, and we are inextricably linked to its mysteries and riddles. Fermi's paradox underlies much of the thinking about the origin of humanity in the universe. Looking into the vast starry sky, we cannot help but be amazed by its beauty and majesty. The universe, with its billions of galaxies and stars, simply breathes life. But why, with such a wealth of cosmic worlds, do we find not the slightest trace of extraterrestrial civilizations? This question has come to be known as the Fermi Paradox, and it provokes endless speculation. There are many hypotheses attempting to explain the Fermi Paradox. One of them suggests that perhaps extraterrestrial civilizations exist, but they are purposely hiding from us in order to observe humanity's progress. Another hypothesis states that we are simply not evolved enough to understand their signals or traces. And of course, there is the view that we may be alone in this vast universe and the search is futile. What if the answer to the Fermi Paradox depends not only on the universe, but on ourselves? We influence the world around us, and our aspirations can have an impact on how we explore the cosmos. Maybe in the search for extraterrestrial civilizations, the key lies in our own actions and aspirations. If there are so many stars and planets, as astronomers tell us, why do we see no signs of intelligent life? This question challenges our ideas about the universe and our place in it. When we talk about searching for life in the universe, we are looking for ourselves among the stars. Neil deGrasse. In the search for extraterrestrial life, we are looking for answers to questions about our own origins and future. Stephen Hawking. The question of the Great Filter hypothesis in the context of the Fermi Paradox is an undeniably debated topic in the spheres of both science and philosophy. It is a landmark question about the development of life, not only on our planet, but also in a possible cosmic context. The Great Filter hypothesis was formulated by economist Robin Hanson in 1996. It offers a possible explanation for the Fermi Paradox, the question of why we do not observe signs of extraterrestrial life despite the vast number of stars and potentially habitable planets in our universe. The Great Filter hypothesis proposes that in the course of evolution, civilizations must pass through what is known as a Great Filter, a stage or stages of development that impede or prevent the transition to a stage at which a civilization can undertake interstellar travel. If the Great Filter lies before us, it implies the presence of a formidable test or series of tests that we have yet to pass. This Great Filter could represent many things: an artificial intelligence apocalypse, catastrophic climate change, nuclear war, biological pandemics, astrophysical events, or even something we have not yet encountered. Despite this, can we say that such predictions are terrifying? Probably, but is it good for our society and our progress in space? On the contrary, if the Great Filter is already behind us, it could mean that we are alone in the universe as a monolith of biological rarity. But what could be the Great Filter? Some scientists, such as Peter Ward and Donald Brownlee in their book Rare Earth, suggest that the Great Filter already past could be the transition from primitive life to complex multicellular life. Professor Nick Bostrom of Oxford University once remarked that if we find complex life on Mars or Europa, a satellite of Jupiter, it would be a bad sign for humanity, because if the transition to complex life is easy, where are all the advanced civilizations? But is it possible that we are simply looking at this question wrong? Maybe, as Ethan Siegel suggested in his 2018 article, we're just not ready for contact. We're only children by the standards of the universe. Could it be that other civilizations are simply waiting for us to become old enough for contact? We are already seeing the barriers between the fantastic and the factual erode with each passing day as interplanetary missions become more commonplace, and we stand on the threshold of what could be the age of interstellar travel. Whether the great filter is in front of us or behind us, one thing is certain: we are at the dawn of a new era of space exploration. But maybe suppose we pass through this great filter, what kind of life will be waiting for us afterward? And what if the extraterrestrial life we seek exists in forms we are simply not yet capable of detecting or understanding? A living world that truly lives beyond our current perceptions and understanding? We continue to research in search of the answer to this question, but will it ever be found? Or will it always remain one of the greatest questions of our time? Solaris, by Stanislaw Lem. The novel Solaris is about psychologist Chris Kelvin, who is sent to a station orbiting the mysterious planet Solaris. The planet is covered by an ocean that has properties that are incomprehensible to mankind. The station on Solaris is inhabited by scientists, but they encounter unexplained phenomena. The plot of the book focuses on the inner world of Chris Kelvin and his interaction with strange manifestations of the planet that create fantastic and even nightmarish images. The novel explores deep philosophical and psychological themes such as perception, memory, and consciousness. The book Solaris by Stanislaw Lem has deep and philosophical reflections that explore the nature of human psychology and interaction with uncharted worlds. Here are a few quotes that highlight the main thoughts of the work. We are surely unable to fully understand what surrounds us because we do not evaluate it through our eyes or through instruments, but through our instincts. This quote emphasizes the complexity of human interaction with unexplored phenomena and worlds, especially in the context of the exploration of the planet Solaris. All external worlds, excluding perhaps our own brains, are simply matter which, outwardly clothed and transformed, meets us as the instrument of our experience. The essence of every matter is that it is not an external world, but an internal one. Lem here discusses the idea that our internal world and perceptions shape our understanding of the external world, and this internal understanding can distort reality. It is interesting how difficult it is for us to get rid of the obsession with our own self, even when it is clear to us that it is just a silhouette on the wave of the sea. Lem, through this quote, explores the issue of self-consciousness and how much our self influences our perception of the world. Astronomers are actively exploring distant star systems, discovering Earth-like planets, and investigating their potential for life. Using telescopes and specialized instruments, we analyze the atmospheres of exoplanets, looking for traces of chemicals that indicate the possibility of life. Science teams are intercepting and interpreting radio signals that could have been sent by other civilizations. Science certainly helps us explore the universe, but human cognition and intuition play a key role in finding answers to complex questions. Great discoveries come from our thinking and research. It's important to remember, we learn to see the world around us from a new perspective, and this can lead to amazing discoveries. The rare Earth hypothesis explains Fermi's paradox by assuming that the conditions necessary for the origin and development of intelligent life are exceptionally complex and rare. There are many factors on Earth that make it suitable for life, including a stable solar environment, the presence of liquid water, the presence of protection from cosmic rays due to a magnetic field and atmosphere, and the presence of a variety of chemical elements and oceans. The hypothesis states that conditions like those on Earth may be exceptionally rare in the universe. They may be the consequence of random processes in planet formation and evolution that rarely create suitable conditions for intelligent life. The origin of life requires complex biochemical processes, including the formation of organic molecules and DNA. These processes may also be rare and require unique conditions. Even if life arises on other planets, the journey from simple microbial life to intelligent civilization can be long and complex. Many factors, such as catastrophes, climate change, and competition, can hinder the development of intelligent life. Because of the rarity of suitable conditions and the difficulty of developing intelligent life, other alien civilizations could also be a rare phenomenon. Therefore, we see no visible signs of their existence despite the vast number of stars and planets in galaxies. To search for extraterrestrial civilizations, we must first understand what life is and how it manifests itself in the universe. Carl Sagan. We cannot solve problems using the same methods of thinking that created them. Albert Einstein. We know that the Milky Way galaxy is old, and there should have been plenty of chances to miss signs of technological civilizations, but we observe silence. Robert Hansen. We don't know what levels of development and different forms of life might exist on other planets, so we only use our ideas about life based on what we know about Earth. Seth Shostak. The concept of the Copernican Mediocritical Principle is closely related to the Great Filter hypothesis and the Fermi Paradox. It assumes that neither our place in the universe nor our existence as intelligent beings is special or unique. According to this principle, the Earth and humanity do not occupy any special or privileged position in the universe. This means that, even though we regard ourselves as a special exception, the probability of intelligent life should be fairly typical in the universe. However, the observed Fermi Paradox is that despite the vast number of stars and planets in the galaxy, we do not encounter obvious signs of intelligent extraterrestrial life. According to this principle, if life is commonplace, why do we not observe it everywhere? The Copernican Mediocritical Principle proposes the Great Filter hypothesis as one possible explanation for the Fermi Paradox. The Great Filter may represent an obstacle preventing the development of intelligent life on the way to interstellar civilizations. This obstacle, or filter, may be related to the rarity of the emergence of life or to some special stage in the evolution of life that is difficult to overcome. It may be the transition from simple single-celled organisms to complex multicellular life, or it may be related to the development of intelligence and the emergence of technological civilizations. If the Great Filter lies before us, it means that we have not yet encountered the difficulties or trials that often arise on the way to an advanced technological civilization capable of interstellar flight. Perhaps we have not yet passed that filter, and we have challenges ahead of us that we must overcome. However, if the Great Filter is already behind us, this may explain the lack of intelligent extraterrestrial life. In this case, we may be a rare exception or one of the few civilizations that have been able to overcome the filter and achieve the development we have achieved. Copernicus's principle of mediocriticism triggers important philosophical inquiries into our place in the universe and the meaning of life. It offers us a more humble position in the universe, emphasizing that the possibility of the emergence of intelligent life should not be privileged for us alone. Thus, taking into account the Copernican principle of mediocriticism, the question of the presence of the Great Filter becomes even more interesting and relevant. Perhaps we have not yet discovered other civilizations because of the presence of the Great Filter, which we have not yet been able to overcome. Or perhaps we need to rethink our ideas about life and mind, looking for forms we have not yet considered. We don't see signs of extraterrestrial life because there's some hurdle we haven't overcome yet. Robin Hanson. It's an interesting and poignantly philosophical question: when to view the future as ethically valid and when to view it as mere potential. Nick Bostrom. The book A Date with Rama by Arthur C. Clarke explores the theme of humanity's encounter with a mysterious and advanced alien technological object called Rama. This book begins with a mysterious event. A huge space object named Rama appears in the solar system. Humanity sends an expedition aboard the spaceship Endeavour to investigate this unknown object. When they step inside the Rama, they discover that it is a huge rotating space vessel with incredible technology. Here are a few quotes that emphasize the main thoughts of the piece. Rama was a machine beyond human comprehension, and as mysterious as the unknown civilization that built it. This quote reflects the theme of human inability to fully understand and unravel the mystery of Rama and the civilization that built it. The study of Rama is meant to reinforce our belief in the unbelievable, in a world far beyond our comprehension, but limited by our ability to know it. Here, the author addresses the idea of expanding the horizons of human cognition and understanding of the universe through the exploration of unexplored worlds. Conversation about the Great Filter hypothesis often includes mention of the Drake equation, which is closely related to the question of the existence of intelligent extraterrestrial life. The Drake equation, proposed by astrophysicist Frank Drake in 1961, attempts to estimate the number of technologically advanced civilizations in the Milky Way galaxy capable of interstellar communication. Drake's equation has the following form: N = RFP NE FL FI FCL, where N is the number of technologically advanced civilizations in our galaxy that can be contacted, R, annual average star formation rate in the galaxy, FP, fraction of stars that have planetary systems, NE, Average number of habitable planets per star system, FL. Fraction of habitable planets on which life appears, FE. Fraction of habitable planets where intelligent life develops, FC. Fraction of civilizations that are able to create technologies for communication, L, is the average length of time a civilization is capable of transmitting signals. Thus, the equation takes into account a number of factors that affect the likelihood of intelligent extraterrestrial life developing and being able to make contact with us. Each of these factors is a micro-theme that can be explored in detail. In the context of the Great Filter hypothesis, the Drake equation becomes interesting because we can reinterpret various variables to estimate the likelihood of a great filter. For example, we might consider the variable Fi, the fraction of habitable planets that have developed intelligent life. If this fraction is small, it may indicate that the great filter is behind us, and we are the rare exception that has been able to overcome the odds. We can also look at the variable Fc, the fraction of civilizations that are able to create technology to communicate. If this proportion is small, it may indicate the presence of a great filter in the form of technological difficulties or risks. Drake's equation highlights the difficulty of estimating the number of intelligent civilizations that may exist in a galaxy. It also helps us realize that searching for and detecting intelligent extraterrestrial life is a challenging research endeavor. Ultimately, the Great Filter hypothesis and the Drake equation allow us to ask profound questions about our place in the universe and the likelihood of detecting other civilizations. Discovery or refutation of the Great Filter hypothesis may lead to new insights and revise our ideas about life and intelligence in the universe. Uncovering the philosophical themes associated with the Great Filter hypothesis and the search for extraterrestrial life can be accomplished through a number of quotes and statements by philosophers who have thought about these issues. Here are a few such quotes that can help us better understand the philosophical aspects of this topic. Carl Sagan noted, "We are stardust that has begun to ponder the stars." Albert Camus asked, "Does man have to leave the Earth to discover himself?" Nick Bostrom is outraged. "Why does a world filled with innumerable stars seem so silent?" Confucius said, "Strive to make your character as perfect as possible, and thus, by perfecting your personality, you will contribute to the harmony of the universe." Philosopher Alan Herford said, "The possibility of space means that the world is a place for unpredictability and adventure." Imagine, humanity develops technology that can simulate life in different universes and timeframes. Each person will be able to exist in their own world and live in it for hundreds of years in one day in the real world. We will only be limited by our mind and imagination. Will humanity explore the universe? If the nearest and immediate purpose of our life is not suffering, then our existence represents a most futile and impractical phenomenon. Arthur Schopenhauer.